Assalamu alaikum. Welcome to lecture number 38 for the subject of software design and architecture, iTech 4129. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, what we discussed in our last lecture, if you remember, we discussed about different role of aspects involved in software design, and then we discussed about different types of stakeholder concerns, where we discussed about five types of concerns for any stakeholder involved, and then we discussed an internet banking system as a cross-cutting concerns example as well, and then we discussed two important aspects of tangling and scattering. So students, it's a little bit recap about our last lecture. So students, let's formally start our today's lecture discussion. So students, here is a brief objectives of our today's lecture discussion. Now in this lecture I will give you an example of tangling and scattering, what actually they are, so will you get more clear idea about these two terms, and then we will discuss about aspect weaving, and then we see software engineering with aspects, and then we see concern oriented requirement engineering, which is very important from architecture point of view, and then at the end I will give you some case study of inventory system, which we actually implement in this aspect oriented architecture with the help of UML as well. So students, this is a brief objective of our today's lecture discussion. So the first of all is tangling. So students, now in our if you remember, in our last lecture we discussed about tangling. So now students, I tell you about the reasons why we need tangling and scattering. So basically tangling and scattering, or we can say, two undesirable situations or unlike situations by any developers community, because this situation normally occurs when we actually require an additional code to implement our core concerns. So that's why these are two undesirable situations, tangling and scattering, which are actually involving the implementation of core concerns, while in traditional programming usually which includes additional code to implement these cross-cutting concerns, like functionals, quality of services and policy concerns. So that's why to overcome this situation we need two kind of undesirable situations, which we call tangling and scattering. So what actually these two situations are? So students, tangling basically normally occurs when a module in a system includes code which actually implements, which you can say, different system requirements. So as you can see in this example, we are going to discuss about tangling for buffer management and synchronization of code. So this is a, we can say, simplified implementation part of code for a bounded buffer system. This is about a bounded buffer system, which is actually illustrated in this code, and our main concern code is a gray shaded area. You can see in this example, I also highlighted there to understand the concept of tangling. So as you can see in this code, implementation of the put operation, which actually adds an item for the buffer. So however students, if our buffer is full, so it has to wait until you can say until a corresponding get operation removes an item from the buffer. So we can, so that's why these details are unimportant. So essentially the wait and notify calls, as you can see in this diagram about wait and notify methods, are wait and notify calls are basically used to synchronize the put and get operations. So basically this code actually supporting the primary concern. So like putting a record into the buffer is actually tangled with the code implementing synchronization. So synchronization of code actually is associated with the secondary concern, So ensuring mutual exclusion has to be included in all methods which actually accessed the shared buffer. So as code associated with the synchronization concern is shown in this shaded area. So the synchronization associated code with the synchronization concern is actually involved in this shaded area. So student, it's our example for tangling of buffer management and synchronization of code. So the next one example is about scattering of methods implementing secondary concerns. So students, what actually are these scattering? So as we discussed, like scattering normally occurs when the implementation of a single concern, normally it is a logical requirement, it is scattered across several components in a program. So this is normally likely to occur like when we can say requirements related to secondary functional concerns are need to be implemented. So this is the situation where scattering normally required. So for example, if we took a example for a medical record management system, like a patient management system, you can say have a number of different components which are actually concerned with managing personal information like medication, consultation, medical imaging, diagnosis or treatment, etc. So we can say these actually implement the core concern of the system, like maintaining record of the patient. So system can be configured for different types of cleaning by selecting components which actually provide the functionality particularly needed for the cleaning as well. So not this is only the case, there is also some secondary concerns as well. So secondary concerns are basically over technical statistical information about like health code provider wishes to record details of how patients were admitted and discharged each month, like you can say how many patients died and what medications were issued, so the reasons for consultations, etc. and so on. So these requirements basically students have to be implemented by adding code that actually you can say anonymizes or anonymizes the data, like you can say to maintain the patient privacy. So that's why we need a statistical component which actually processes the statistical data and generate the statistics reports that are required for our patient management system. So if you if as this is a patient management system diagram, if you can see about this how second scattering of methods are actually being implemented in secondary concerns. So this concept is actually showing in this figure, which actually shows the example of three classes that might be included in the patient record system along with the sum of the core methods for managing patient information. So the shared area or shaded area in green coloring, you can see that are basically the methods that are required to implement the secondary statistics concerns. So you can also see that in this diagram this statistics concern is scattered through the core through the other core concerns. So this problem with the scattering and tangling usually occur with the when over the initial system requirements are normally changed. So this diagram is actually tells us about if you can see in this shaded area, gray shaded area actually tells us that about how the methods which are required to implement the secondary statistics concern. So you can see this in this statistics concern is actually scattered through the core concern. So it is an practical example of scattered how scattering is actually being performed, as we can see in this diagram in this gray shaded area, which actually shows how these methods are need to be implement the secondary concerns, and this gray shaded area actually tells us that how this concern is actually scattered through the other core concerns. So this is about scattering. So students, this is a very good example for about scattering, how we need to implement methods for secondary concerns, as you can see in this gray shaded area. So the next important point is about aspect weaving. So students, before I start aspect weaving, I would like to remind you these two terms are we have been discussed in our last week lecture. So what are aspect and weaving? I am assuming here that you are now aware about what are actually aspect and what are actually the weaving. So students, this is also an important diagram about aspect and weaving from our most basic patient management information system. So student, if you can see in this diagram, This diagram basically shows that shows the aspect viewer for authentication and logging aspects. So authentication and logging are our two aspects which should be implemented in our patient management system, you can say. So how we can implement these three how we can implemented these authentication and logging as aspects in patient management information system. So we can implement these authentication and logging by using three different approaches of aspect viewing. So what are actually three approaches of aspect viewing? Source code pre-processing. So what actually it is, students, basically source code pre-processing is a most basic technique for aspect viewing. So basically this is normally used where you can say a viewer takes source code as an input and generate new source code in a language can be Java or C++, which then can be compiled using the standard language compiler, whatever the standard compiler language is available. So this approach has been adopted for the aspect X language with its associated X viewer as well. So it is actually built by Birrer in 2005. And the next important approach for aspect viewing is link time viewing. So actually what is link time viewing? So this is normally the situations, students, where the compiler is modified to include an aspect viewer. So in aspect oriented language such as we have a aspect J framework which actually processed and standard Java bytecode is generated. So this can be executed directly by a Java interpreter or further processed to generate native machine code. So this is a link time viewing. And the third approach is dynamic viewing. So what is the dynamic viewing? So as its name suggests, dynamic viewing is actually at execution time. So in this case our join points are monitored. What are join points? We already have been discussed. So in this case our join points are actually monitored, and when an event that is actually referred in a point cut occurs, so the corresponding advice is actually integrated with the executing program. So this is actually about dynamic viewing at execution time. So students, in my practical knowledge point of view, in industry most commonly used approach to aspect viewing is normally link time viewing. So as this approach actually allows for the efficient implementation of aspects without a large runtime overhead. So dynamic viewing is, we can say, is most flexible approach, but it can incur significant performance penalties during program execution. And about source code pre-processing is now rarely used. So we can say link time viewing and dynamic viewing are two mostly approaches which are normally utilized. So mostly link time viewing is utilized, and but dynamic viewing is most flexible, but it lack of significant performance penalties during a program execution is a drawback for dynamic viewing. So that's why link time viewing is mostly used. So the next aspect is about software engineering with aspects. Software engineering you already have been discussed in your previous semester as well. So students, if you look into this diagram, so in this diagram actually I have used UML packages to represent both the core and extensions. So here is this is a generic diagram. We have some core system, like you can say we have a patient monitoring system. I will also provide you a core system and extension diagram of patient management system in our later lecture, but here just you need to understand the basic skeleton of about aspects in software engineering, how it actually involved at the architecture or design level. So this diagram actually I have used UML packages to represent over both core and its extensions. So what are actually core system? So core system are actually our system features that you can see that students you can say implements the essential purpose of a system. Therefore we can say if the purpose of a particular system is to maintain like information on patients in a hospital, then the core system actually provides a means of creating, editing, managing, accessing a database of patients record, etc. So while if we are talking about extensions, so the extensions to the core system actually reflect additional stakeholder concerns which must be integrated with the core system. And what are the stakeholder concerns? We already have been discussed in the previous lecture, where we discussed total 5 stakeholder concerns. For example, I say it is important that a medical information system maintains the confidentiality of patient information. So one extension might be concerned with like access control, and other can be encryption, etc. So students, extensions, we can say, always add some kind of functionality or additional feature to the core system. So most important, now here I am concluding that aspects are basically our way to implement these extensions, and they can be composed with core system functionality, like using the viewing facilities as we see in the aspect oriented environment as well. So you should note the important point here is that aspects are basically provided as a way to implement these extensions, and they can be composed with core system functionality using the viewing aspect as well. So students, it's a basic skeleton about what are actually are the core system and what actually are the extensions, and how aspects provide us a way to implement these extensions, and how these can be composed with core system functionality. So I will also provide you a generic model for aspect oriented design for our, you can say, patient management system for this core system and its extension as well in our next lecture. This is a generic idea about what actually are the core system and what actually are the extensions, and how extensions helpful where we utilizes the aspects to implement our extensions. So students, the next important aspect is about concern oriented requirement engineering. So students, requirement engineering is as you know, is a first stage of software development life cycle. So all of you are actually well aware about software requirement engineering as well. So if you look into this diagram, students, before we start this diagram, there are also, we can say, some kind of requirements. So requirements are something, you can say, you wanted, your necessities are your requirements. So basically you can say requirements, there are some requirements which actually cross cut all viewpoints, as you can see in this figure. What are the viewpoints? Viewpoint is basically a strategy for requirement engineering technique. So as you can see that in this diagram, our main concerns for this are regulation, security, and dependability. And here on the most top sides, left side, sorry, our viewpoints are written like equipment, users viewpoint, managers, organizations, and society. So viewpoint is basically an requirement engineering technique from equipment point of view, from user point of view, for managers point of view, organization and society point of view. So all of these viewpoints are basically gathered in software requirement engineering. So you should just need to know about that viewpoint is basically a requirement engineering technique. So this diagram actually shows that the viewpoints may be different type, but cross-cutting concerns like regulation, dependability, and security generate requirements that may impact on all of the system viewpoint, as you can see in this diagram very clearly. Our concerns, I am again explaining, a viewpoint may be different type, but cross-cutting concerns like regulations, dependability, and security, which can be seen in this figure, generate requirements which actually impact on all of the system viewpoint. So students, this was the major consideration of this concern oriented requirement engineering, about what actually viewpoint and what actually it tells us. So students, we can say, like, to develop a system which need to be organized, we can organize it in a term of core, as we see in our previous example. We can organize our system in terms of core system and extensions, and the other way is to organize our system in terms of concerns and viewpoint. So basically a viewpoint, we can say, a viewpoint oriented approach to requirement engineering is basically where each viewpoint represents a requirement of related groups of stakeholders. Like users, managers, organizations, and societies are our group of related stakeholders. So these are our viewpoints from multiple stakeholders, which are actually belonging to different groups. So here is a you can see that basically it is a one way to separate core and secondary concerns. So if you organize the requirements according to stakeholder viewpoint, and then students, you can then analyze them to discover related requirement that appear, you can say, in viewpoint. So these actually represents the core functionality of the system, and other viewpoint requirements may be requirement that are specific to that viewpoint. So we can say that these can be implemented as extensions to the core functionality. So here you just need to know about that what are actually your concerns, and how regulation, security, and dependability are our main concerns, and how we have a viewpoint requirement engineering approach, and how we have viewpoints from a related group of different stakeholders, and how these viewpoints can be achieved in all concerns. What kind of concerns are here? Primary concerns, regulation, security, and dependability are primary concerns. So basically it actually depicting the concern oriented requirement engineering, how we can perform our requirement engineering in terms of concern oriented approach. So as we see earlier, we have a concern oriented design as well, concern oriented requirement engineering as well. So here you can see that how different viewpoints can be implemented to our relevant concerns, so that the related group of stakeholder viewpoints can be achieved in all concerns. So actually it tells us about concern oriented requirement engineering. So the next here is a case study, students, for you. You just need to get an idea about it. In the next lecture, I will provide you some UML diagram for it to understand about the about aspect oriented design, how actually it involves. So it's just for the information about. So C1 for first core requirement and C2 for second core requirement, and this is about for inventory system. I am lefting this part for your self study. And the next are the extension requirements, and extension requirement, E for extension and C for core. And for first core requirement we have 1.1 its extension requirement, and now further this for 1.1 requirement we further have its 1.1.1 extension requirement. So here you can see the core requirements and extension requirements for inventory system. So you should self study these core and extension requirement. I will provide you more details about the inventory system with the help of use case diagram. How use cases are used in terms of aspects will be discussed in our next lecture. So students, still here our lecture number 38 is ended.